Hello, everyone. Thank you for joining us today. My name is Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. We'd like to begin today's program by saying a very big thank you to Aerospike for sponsoring our webcast, and we'd like to let you all know Aerospike is the world's first in-memory flash-optimized database, an in-memory NoSQL database that does at least three things really well: speed, scale, and rock-solid reliability. Aerospike makes scaling easy. It powers 2 out of the 3 of the biggest real-time bidding platforms that operate at or near Google scale, platforms like AppNexus, BlueKai, Chanco, Exalate, and X+1. Some databases are fast, some databases scale, and traditional, relational are reliable. But no database operates at extreme low latency, under 1 millisecond predictability, 95% of the time, while also scaling to well over 100 terabytes of data and doing all this nonstop. Around the clock, 24/7, with no service downtime and no data loss for almost 4 years now. Thank you again, Aerospike. Folks, joining us today from Aerospike is Brian Bulkowski, and he's going to talk to you about TPS and TB, when to scale up and how to scale out. Brian is the founder and CTO of Aerospike, has 20-plus years experience designing, developing, and tuning networking systems and high-performance web-scale infrastructures. He founded Aerospike after learning firsthand the scaling limitations of sharded MySQL systems at Aggregate Knowledge. As Director of Performance at this media intelligence SaaS company, Brian led the team in building and operating a clustered recommendation engine. Prior to Aggregate Knowledge, Brian was a founding member of the digital TV team at Navio Communications and chief architect of cable solutions at Liberate Technologies, where he built the high-performance embedded networking stack and the internet-scale broadcast server infrastructure. Before Liberate, Brian was a lead engineer at Novell, where he was responsible for the AppleTalk stack for Netware 3 and 4. Folks, we're really excited to have Brian with us today to present this webcast for you all. As we get the event started, I'd like to go over a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Brian. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Brian, please preface them with a capital letter Q so we know that they're for him and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is VelocityConf, all one word. If you should have any trouble with the webcast, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. If you have any choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is to close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Brian for his presentation. Hello, Brian.
Hello, Yasmina. So it's great to see all of you who have decided to show up for my webinar today. I see 65 attendees right now. I know you have busy days, and so let's just get started. So I founded the company Aerospike, NoSQL database company, because I saw that there were serious problems in delivering at-scale services on the Internet. I saw companies troubled and having difficulty delivering some of the most demanding applications. Folks at Yahoo, folks at Amazon trying to put together high-velocity services. And even though they had the technical expertise and the budget to hire the world's best, they still had problems. And as someone who had been in Silicon Valley for 25 years and a programmer and technologist all my life, I thought that it would be time to found a database company based on the capabilities of scale, the abilities of modern in-memory technology, not just low-cost RAM, but also flash, and bring the kind of scalability that was possible at the levels of uptime and reliability to a broader market. And I've been very excited to work with some of the most cutting-edge, high-scale companies on the entire Internet today. And I've seen recently a huge level of increase in the number of companies that are reaching the level of scale that was previously thought very, very difficult. So I'm going to tell you a bit today about how these companies are doing that, but also why they're doing it. The different market segments that I see and the different people I talk to who are trying to reach millions of transactions per second, and why. When I talk to traditional software vendors, I won't name names, but the larger companies, they say, oh, that's just an advertising problem. But what I see today in businesses is the need to understand users, the need to be able to take not just market information, but personalized information from across the Internet and create a very compelling experience. We're all out there on the Internet competing with the likes of Facebook and Google for eyeballs and attention. And so the pressure on us technologists is ratcheted up to use the best technology and create the best software stacks. So where we started was the fact that advertising has reached a broad level of technical capability. Social media, retail, travel, financial services, these are all segments that have also started to reach the same levels. So I'm going to show you those cases, and feel free to ask questions at any time. I have the Q&A window up here in the webinar session. Feel free to ask questions. I like to keep things interactive. And once we go through some of these use cases that I'm starting to see, I'll give you some of my recommendations and best practices based on the technologies I've seen actually work in some of these new next-generation companies. So why do companies really start needing the ability to work at very high levels, what was previously very high levels of scale? And the issue is really all about customers. And what we talk about is we talk about application-built and application-driven technology stacks, where there's a level of fit and finish and polish and interaction that goes far beyond static websites and the ability to have shopping carts. Today what we need is we need daily deals, we need reasons to cross-sell, we need products that work with other products, we need recommendation engines that are responsive and not static, we need the ability in financial services companies to look at your tradings on both mobile devices and also internet display devices, a wide variety of use cases. And through all of this, we now have the pressure that services can't go down. When your boss sees that the website of your company is offline for even 4 or 5 minutes, he'll start asking why. The common thing I hear among CIOs and CTOs is, well, if Google can do it, why can't you do it? We're a large company. We have resources. You can go hire teams. As technologists, we know that it's not that simple. The ability to bring together technical teams and inspire them can be difficult, and doing that at different companies may be a long haul. So the pressure is to deliver the level of services that other companies are delivering, the larger internet companies, and compete for eyeballs on the internet with the resources that you have at hand. So where this has taken us just in the last 18 months, according to some analysts at Emulex Labs, is the ability to take terabytes and drive businesses from just a few hundred terabytes up through many hundreds of terabytes. So the ability to drive larger levels of scale is happening across many different businesses. So let's go into a few details. In the retail banking sector, what we have found is internet companies such as Yahoo and Amazon simply entering into the market. There is now a bank that Amazon owns where they will be providing internet services. There is Google Wallet, and even PayPal is starting to feel the pressure as an internet company. Companies like Amazon are using their same disruptive playbook and trying to use the retail establishments that companies like Citibank and Bank of America and Wells Fargo have long seen as their pride and joy, and saying, well, why do you really want to go to a bank? You don't really want to go to a bank. You just want banking services. As an internet company, we can deliver a faster, easier, higher quality level of service, just like they did with books, just like they've done with retail. So that disruptive playbook is already starting to happen, and the folks who inside the traditional retailers and traditional bankers have, of course, seen the writing on the wall, and they know that they have to build out the same kind of data layers that have driven some of the internet companies. Let's go through for a second the innovators in advertising, because these were the guys who first started working at much higher level of personalization. So for those of you who don't know as much about what has happened within advertising in the last decade, it's a fairly interesting story, and Aerospike has been in the middle of this ecosystem providing technology. So what happens in the typical advertisement, whenever you go to a web page, whenever you're on a mobile app, even these days whenever you're on Facebook, is there's a set of publishers on the left-hand side that have ad space that they are trying to fill. They want to make money. They have an impression. They're satisfying users, driving users to their site. They want to place advertisements because that advertising payment drives the internet. These companies then go to ad networks. An ad network is aggregating content from across the internet and also aggregating the advertisers shown on the right-hand side that have advertisements to place. In the very early days of the internet, an individual advertiser or media buyer would talk directly to one of the websites or properties and buy individual space on individual pages or a set of pages. And delivering advertisements was simply a matter of flipping through and randomizing a set of banner ads. So it was site by site. That was, say, early 2000, between 2000 and 2004, and was fairly easy technologically because each site was separate and could scale according to its own size. However, what the advertising companies found and the publishers found was they needed a broader range of advertisements. And the idea of real-time bidding, which is a process in advertising of matching individual users to advertisers, not just a website or a display and buying site pages on that, instead trying to buy eyeballs or time in front of an audience. Because you're really trying to reach an audience. You're not trying to place content on a page. That core innovation was used first by Yahoo and Google. When Yahoo bought Right Media in 2007 and Google acquired DoubleClick in early 2008, that started the revolution. Those two companies started saying, hey, let's buy audiences, let's not just buy websites, and let's start doing internet advertising in a new way. In order to do so, they needed a much higher level of personalization. Every request, called an impression that came in from a publisher, was time in front of a person, and they needed to separate out the different components. Is it better to contextualize the ad to the page, or is it better to target the ad at a person to create a brand impression? Well, there's a lot of factors and a lot of math that can go into making that decision optimally. And Yahoo and Google, through the Right Media and DoubleClick teams, really found new algorithms and new ways of doing that. And in doing so, they created new technology stacks to operate at this level of speed. Further, these black box advertising systems in the major internet advertisers came under competition from ad exchanges like AppNexus and the Trade Desk that you see on the demand-side platform page, as well as data management platforms. A data management platform is collecting some of the information from various different content sites that allow sharing and through opt-in systems. and allow various different advertisers the ability to do a finer level of optimization and personalization than they could before. Data management companies have been a key part of the advertising revolution that started up around 2008 and 2009. But the exchanges, where many different advertisers would come together, really drove a new level of scale. What we saw in this ecosystem, which is called real-time bidding or RTB, that also exists in a few other advertising markets such as India and Japan, lesser so in Europe for a variety of reasons, is a drive to scale where every user profile needs to be stored and needs to be online for personalization and optimization. They are typically tracking these days, the major guys, about 1 to 6 billion cookies. Now, some small companies are smaller and are tracking around 200 million cookies. Some are larger and tracking closer to 20 billion cookies. So imagine a table in a database of that size. That's going to place some strain, really a lot of strain, on traditional relational implementations. These companies have different ideas about how much data to keep per person. What I find in the industry is an average of about 1.5 kilobytes per cookie. Now, these companies are very careful about staying on the correct side of the law in terms of personalization, and they separate out what's known as PII, which is to say personalized information, that is, they are legally required not to keep. So you won't find any phone numbers in there, and you won't find any names or addresses or email addresses. You'll simply find recent behavior from a particular cookie, which is absolutely allowed under the law. However, with all of these cookies, companies found at first they were using client-side cookies, if you remember, up till about 2008, and then they started realizing that multiple devices and higher levels of optimization, they could store more information per user than in a typical browser cookie, and they started moving that data through server-side cookie management into their own data centers and into their own systems. Each one of the players in that big advertising map I showed, they make money by having their own data. They have all of their own math, what's called search retargeting for recent search terms to determine intent. They look at what's called lost cart analysis. If you were recently on a site and tried to buy something and put it in a cart and you're thinking about it, there's someone on the internet who knows that and is going to try to get your business now that you've demonstrated that intent. So what we're finding in this ecosystem is folks who are delivering about 2 billion transactions per second, 2 million transactions per second, and about 100 billion auctions every day. Now, when I talk about auctions, what I'm talking about is in order to price each one of these advertisements and each one of these, as they say, impressions, a particular person at a particular time on a particular website with a particular history, they decided in advertising that is so fine-grained that it's not like a capital market where you have a stock that's the same stock as it was yesterday and is the same stock tomorrow. This is a very fleeting kind of transaction, and it needs to be priced immediately due to all of the factors. So in real-time bidding, an auction is run, just like an auction on eBay. This kind of auction technology wouldn't have been practical 10 years earlier, but with cloud technologies, database technologies like Aerospike, and some of the other warehouse technologies and big data technologies like Hadoop, it became practical to actually run all of these auctions within about 10 milliseconds. The constraints on timing were driven by personal interaction. Early in about 2004, some of the large-scale internet websites like the Washington Post, that are news sites, started placing a lot more ads on every single page. Some said at the time that it was getting out of control. But what happened at these content sites is they said, hey, our site is getting slow. We're contracting with all of these advertisers, and you know what? Some of them are not delivering at scale. And so these content sites, in order to make sure their sites remained responsive and fast, created a contract. And that SLA, Service Layer Agreement, said that every ad must be delivered to every of their browsers, every end user on the internet, within 100 milliseconds or 150 milliseconds. There are two different SLAs that came into contractual use. As you know, that is the feeling of snappiness. There's a human perception limit around 100 to 150 milliseconds. But let's break that down a little bit. North America is about 70 to 90 milliseconds wide. And so in order to deliver an ad to a browser, you need to reserve that amount of time for actually delivering the ad. And you have to take into account how large the ad is in order to deliver it. Video ads, of course, need to start pre-rolling, etc. So out of that 100 milliseconds to 150 milliseconds, ad delivery, simply the delivery of the ad, was listed as 70 to 90 milliseconds, leaving a very short budget to actually do these auctions and determine which ad out of the 100 companies and thousands of current advertising campaigns in the world might be chosen for this particular person and this particular site. So the idea of running an auction at this level of scale for every single person in an open marketplace was really innovative in 2008 and drove a whole new level of technology. So this slide shows the technologies that came into use in order to meet this demand. Of course, a service like this has to remain up. If you are buying space on content websites and suddenly a large internet event occurs, if you remember, the death of Michael Jackson was one of those spikes. Nobody predicted it. And suddenly at about, I believe it was somewhere around 2 o'clock in the afternoon Pacific time, that death announcement was released, and suddenly internet use spiked a factor of 2 or 3. All of those ads and all of those impressions, those are all money to content providers, and they had different architectures, static, cache-based architectures that could handle the load. And the internet advertising systems, which were doing personalized, much more fine-grained content, also needed to survive at these levels of scale. Those big black swan events really drove the imagination of a lot of the technologists in Silicon Valley and Manhattan to really contemplate what kind of service would survive under near immediate load spikes of 2x, 3x, 4x, because that's what the internet is about. The internet has a steady level of load, but then sometimes has massive levels of load. In order to achieve this, these companies really separated out the operational database from the data warehouse. Now, in some ways, this is a very old technique, and I'll go into some of the historical aspect of separating out warehouses. Now, of course, the new technologies are big data technologies like Hadoop, and the front-edge technologies are distributed in-memory databases, and we'll take you through exactly how that happened. But the advertising technology stack that became available starting in around 2008 has now reached a much greater level of audience because of internet use cases being applied to enterprises. I'm going to go through a few of those cases right now in some more detail to try to show you and perhaps create some imagination in your business and your market as to where this technology might be applied. So some of the leaders in financial services, in retail websites, have started to realize that they are going to need a much greater level of load for all of the same internet reasons. So they would like to start as a retailer presenting more deals, and they need a higher level of consistency. They have traders who are coming in on one side, being able to make a trade on your behalf, split trades out, tell you information about your trades in progress, and in-house trading systems that are very rapid. But more importantly, they're seeing a lot of new load created by new applications, what's called portfolio rebalance applications, and also the use of mobile. So the old systems for intraday positions used typical DB2 or other relational mainframe systems and placed caches in front of them. However, that inconsistency of multiple caching layers leads about 6 to 10 milliseconds of cache inconsistency. So there were cases, and are cases today in these systems, where if you go through the mobile portal, you'll see a different set of stocks in your current account than you will if you go through your website or if you call up your trader. And this is seen as completely unacceptable, of course, in financial services. And so the level of consistency that is needed at a very high level of scale. These companies are now planning for and attempting to achieve 1 million transactions per second when they add up all of their data and data loads from applications. So this is all driven, like I said before, by new application cases and the ability to bring forward new imaginative use cases, even with something as seemingly old as financial services. Now, the ability within social media companies has also really pushed this technology base. I had the opportunity to do some webinars in China and also talk to some of the leading social networks today. For example, I talked to Pinterest last week, and I see one technology stack over and over again that is driving a lot of the innovative companies. What they're doing is writing an application and then using a data abstraction layer just beneath it. And I'll go through some more specific best practices for this. That data abstraction layer is not a query layer. Instead of using some kind of query system that can reach out to different databases but allows a wide variety of queries, they create an application-specific language, an SOA architecture in slightly older terms, that is specific to their content and specific to their business, that the application writers, people in charge of doing user experience and driving new user experiences, can build off of. Then there's a separate group responsible for delivering that one API at new levels of scale. So that one data abstraction level, that contract between application writers and essentially DevOps DBAs, is critical to a new level of scale. By having this data abstraction layer, I find that many companies have switched to using modified versions of Redis, a key value in-memory NoSQL store, as their primary system, but also having side-by-side some of the older internet scale systems such as MySQL and Postgres. So these are the systems driving, for example, Weibo, which is the Twitter of Japan, as well as Alibaba and Tencent. They're running at amazing levels of load through the Chinese system, but also able to provide great application level advantages. I've also seen within the travel business a lot of interesting innovation. I'm sure many of you know that travel companies and airlines in particular have been on the forefront of technology innovation because in the early days of airline travel, they were one of the few entities that was able to transfer money and in fact started some of the early banking systems and credit card systems. If you remember, there was no such thing for a while as an interstate bank, and yet someone doing air travel wanted to leave one state, arrive at another state, and still be able to pay for their hotel room or dinner. That created a lot of need within travel companies to generate more airline traffic and happiness with the airline system to start innovating within financial services. Today, travel portals, we all know from the early days of the internet, were some of the first online businesses as well. Companies like Travelocity and Orbitz linked into the online Sabre system, which is using older style AS400 mainframes, and tried to really innovate in real-time pricing, real-time seat reservation on a very fine-grained level. In order to do so, they created a lot of caching layers between companies, and unfortunately, those caches still survive. So today, you have the problem where even though sophisticated real-time pricing models in travel portals are out there, you have the case where you can go to a website, search through your seats and choose one, and then find out, oh, that seat is no longer available at that price or that plane is already full. Companies in the travel industry are starting to look at the internet architectures that are cashless in order to start avoiding that kind of problem. If you have a database without a cache, just like I was saying with financial services, you don't have that inconsistency problem where you ask one guy and he says, yeah, I think it's that, but you know what, there's an underlying database and we might be out of sync. So the other thing that happened within travel is because of a service-oriented architecture between companies, you have, say, a travel portal, but you have tickets owned by, say, a United or a US Air. That company is actually responsible for the price, And so Travelocity, or a website, wants to use an API to go and find what is the current seat levels. Well, those today are done through a system where a website has to pay just for determining what the pricing or availability of a seat is. This creates a lot of problems because the travel sites then start putting caches and creating a poor user experience. This entire industry is starting to look at how to remove caching layers simply to create a better application design and a better experience. Another interesting case that I've heard of recently is in quality of service within networking companies on the Internet. So quality of service, for those of you who are involved in the history of the Internet, has long been an area of research and contention that hasn't had great resolution. Instead, as networking and technologists, we've found that networks tend to increase in speeds and don't need as much optimization as they did. It was always better to simply wait for the next generation of Ethernet, next generation of fiber, next generation of long-haul networks, than work terribly hard about priority queuing, red-black queuing, and other quality of service systems. However, I'm starting to see quality of service rearing its head again within network operators. Instead of using older systems in QoS from the 90s that required an application change where an application had to specify what quality of service, say this is a voice call, this is a video, this can wait because it's an interactive session. Instead, these companies are starting to look at doing packet inspection in order to make sure their networks don't congest. This requires, essentially, a database lookup on each and every packet on their Internet and through their routing subsystem, an idea that was previously unheard of. The idea of doing a database request in the middle of your fast routing loop in a high-performance network would be considered crazy, and yet the level of velocity that I'm starting to see as requested is in the area per, say, metro area of 100,000 to 200,000 routing decisions per second. This is absolutely within the area of current technology. Now, it'll probably take a few years for those innovations to roll out, but that's another idea where someone within these companies has figured out that by using new database technology, they can really achieve something that's already been proven in the advertising stack and deliver new services. I've also found within retail, especially, the ability to and appetite for creating real-time deals and different kind of interactive systems. So in the older world, many of these companies created static pages and simply relied on content delivery networks to deliver the same catalog page over and over again. The greatest innovator, one of the greatest innovators in this space recently has been Walmart. In their ability and capabilities of doing battle with Amazon in terms of price and in terms of responsiveness, user reviews, etc., Walmart has really innovated in using big data techniques to both drive traffic but also consumer satisfaction. If you think about Walmart's core values of tracking a store, each and every store separately, looking at product positioning on shelves, and really doing as fine-grained great job as they can, applying those same principles to the Internet means more personalization. And some of the stories that have come out of Walmart, I admit many of them are rumors, has started to drive other companies to say, you know, we need to do a lot more personalization, and yet our tech stack is based on static content and content delivery systems. We need to add real-time delivery and use the big data techniques that companies like Amazon and Walmart are using to, on a moment-by-moment basis, reach out to anyone who comes into our website. Previous analysis in retail said, well, only maybe 5 to 10% of users log in, and therefore personalization is not cost-effective. However, some players have found that the interesting users are those who don't log in. Those are people who don't have brand affinity, who don't necessarily share a 360-degree customer relationship, who you can't push emails to. Those are actually the interesting customers. Those are the ones who you want to do more to drive, to personalize, to create a better experience, to get greater brand affinity and keep them coming back. So without a login, these companies are reaching for internet and advertising technologies to tailor websites, but to do it on the front edge of their application, where it's most visible and where services need to stay up. So hopefully, in this discussion, I've taken you through a wide variety of use cases that really show how the innovations in advertising technology from 5 to 7 years ago are being applied in more and more interesting use cases. Let's go through in more detail what this technology looks like. The new architecture within these technology stacks, first of all, has plenty of big data and analytics on the back end. What I've found is this part of the technology stack has many different providers, and providers come and go. Since this side of the architecture is not on the real-time and responsiveness side, if it goes down for a few hours, if there's a delay or a hiccup in one of the analytics databases, perhaps it means that that part of the site won't be quite as fresh, but the site will still be up. So what I find is the best practice is using many different types of analytics databases, column stores, real-time stores like the innovative Spark system, Netezza systems, Hadoop systems. Some of our advertising customers have told me they have literally 15 different kinds of databases, all using different query patterns and different optimizations because they're doing research. They don't really know which optimizations are going to work and what data patterns and query patterns will be effective. So they bring in a new analytics system constantly in order to do new kinds of analytics for their data scientists. On the front edge of their application, you'll see also that what's old is new again, in that operational databases, as we used to call them, are what is tied to an application service tier. These are now NoSQL databases in these environments simply in order to keep up with the scale and responsiveness required. So what we saw in the old scale-out architecture prior to, say, 2000 was that front-edge application tier contained really three parts of a database. Besides having a load balancer and an application server tier, there was usually a cache, a relational database, and then a storage layer. By having this three-part architecture, the necessity of reaching high load was that caches would speed up reads. Writes, well, you would have to manage them very carefully, and you often wouldn't create very high throughput write systems. You'd have to manage those carefully because you couldn't cache your way out of high write loads. Every write had to hit a database. Now, a sharding system was part of the answer to that, but storage layers also were able to scale out horizontally, and you would typically add more and more cache and more storage to a system simply in order to be able to take writes. So these systems, to give you a quick story, my co-founder, a database guru from the University of Wisconsin, America's great database PhD school, he was tasked one day with scaling out Yahoo Mobile. If you remember Yahoo Go, which was made available about 7 or 8 years ago, that was an acquisition from another smaller company, and my partner Srini was tasked with taking an innovative online experience that Steve Jobs showed in the very first iPhone release and taking it to Yahoo scale. He used the best practices of the time and bought an Oracle system and a very large NetApp filer storage layer, the best that could be had, and put a cache in front of it, and still found that as load increased for the innovative system that Yahoo had for notifications and mail on the iPhone, that the system crumbled. He was on the phone with database administrators constantly as the site would go offline for 5 minutes and 10 minutes at a time, get re-optimized, come back up, and go back down. This system, even though it made a lot of promises in terms of scale, was not able to deliver. The kind of architecture that we're now seeing that actually delivers the level of reliability but also performance that I talked about through those use cases, tens of terabytes and hundreds of thousands of transactions per second, is one that collapses that previous three-tier application side into really just one database level and one application server. Now, application servers have started to modernize as well with technologies such as Nginx, Node, and Scala Jetty-based Java systems. We're starting to see a lot less application tiers that are older school, let's say JBoss systems, even though Java is still a very performant system. And I'm also seeing companies that start in the internet space, say using PHP, migrating to some of these higher performance application servers. The way to think of this in a historical perspective is the app server is where your computation is. The database layer really becomes the storage layer, but the application layer, that's where your CPU is consumed and where many database requests are chosen and the application is made rich. So your developers are putting together using asynchronous interfaces and new event-oriented architectures more demanding applications at the app server level. What is critical for scalability is that this is a stateless app server. This meshes with the kind of cloud deployment, either public or private cloud, that allows you to very quickly and simply respond to compute-based load by firing up new app servers. No data has to move when you bring in a new app server if it's a stateless app server, and the storage layer is provided through an in-memory NoSQL database. So the technologies that have caught on with in-memory NoSQL are companies like MongoDB that provide very easy developer use and allow people to get started with their document-oriented design very quickly, as well as Cassandra that provides a very wide level of scale. Cassandra's strengths are the ability to put together clusters very, very quickly of very massive size, so a very high scale-out system. What Aerospike provides in this exact tier is both scale out and scale up. I'll talk a little bit later about some of the core benefits of Aerospike in this regard. What we find on the research warehouse side is not just the Hadoop, HBases, and other systems. I find that a new trend is using HDFS as the storage layer. I see a lot of innovation in different query managers that are all HDFS-based, and I believe that the transition to an ETL-less world with one storage layer for research will likely be based on the HDFS interface and HDFS storage layer. This is, in some sense, parallel to the trend on the operational side of having compute driven at one layer and storage at the database layer. On the back end, research, warehouse, and big data side, we're starting to see more innovative query systems like Apache Spark, driven by Databricks, as well as various SQL implementations that are also Hadoop and Yarn-based, all driven on one data set using HDFS. This is a very exciting idea because it gives the different query plans and different query optimizers all access to the same research data. So let's go through some specific recommendations that I've seen in different implementations for how to actually achieve this on a day-by-day basis in your organization. So first, I mentioned early on in passing is an agile application layer. Now, in some sense, this is standard good programming practice and design. However, what I have often seen is an application is designed and a set of queries are created against a traditional database. But in an agile world, those queries start changing. As soon as an application developer gets a new idea, has new research data that shows in an A/B test that a particular design is working better, they'll often want to add new application features and will start doing new queries in new ways that will put unknown and unforeseen stresses on the data layer. By instead creating an application layer that is specific to your business, what I find is that that allows a scale-out team, really the parallel of an old DBA, to actually build in different databases and switch in and out database technologies as they see the load changing. So this I first saw in use at some of the social networking sites, like I was mentioning some of the Chinese and also American sites. But imagine, just to set your level for it, instead of having an application that does any arbitrary SQL query, An application has a predicate like get my list of friends or get a recommendation based on this particular user. Then you're starting to split out some of the high-scale network requests from the UI and UX elements that can be innovated on rapidly. By separating out some of the scale layers from the application layers in this one interface, I believe you'll find you'll be able to pick appropriate database technologies and scale your system faster. So the second recommendation is the use of key value stores and the use of key value paradigms as the primary way to access databases using in-memory NoSQL. Now, this may come as a surprise to people used to the flexible and rich query semantics of SQL, but what technologists have found time and time again is key value access, which in database terms is called primary key access, is really the key to performance. Using joins and using different database techniques like joins was a way usually to save space and storage, as well as to create application logic. By using normalization techniques and never store data twice, databases became more compact, which was really a great optimization within a single server system. However, in a distributed system, which is the new best practice, we find that joins are really one of the devils in building scale-out ecosystems. In-memory is very important because an in-memory technology allows you to change the database load and the application with minimal impact on the underlying system. Since an in-memory system is very good at random access, does not rely on caching tiers, and does not rely on data storage layers that are particularly formatted, let's say with materialized views, you'll start finding that a system like an in-memory system, an in-memory NoSQL, first of all is delivering a higher level of performance, but most importantly, a high level of predictability. In memory, it doesn't matter if it's in cache. It doesn't matter if you accessed this user and that user next to each other. You get a much higher level of predictability, and that's what these companies demand. You need to have a level of predictability that's not access pattern based. The advertising companies learned this because the scramble is usually in North America around Black Friday, the area right before Christmas, when suddenly user behavior changes, and every year is a little different. When I was talking to a friend at an advertising exchange, they had just gone through the most recent U.S. presidential election, and they found that load doubled, and all of the caching numbers that they had went out the window. Yet the fact that they had in-memory NoSQL and were based in key value access meant that they survived that spike very easily. So focusing your application on key value, that's not to say you only use primary key access. You still need queries in some cases, and you need to be able to look at multiple rows and access queries. But if you really focus your application developers on primary key access and use application development paradigms that focus on primary key access, user IDs, user storage, you'll find you'll be able to achieve much higher levels of serviceability, much higher levels of uptime, much higher levels of performance. And so the benefits of in-memory NoSQL are, first of all, the ability to handle random loads and changing loads very predictably. However, and some of the technologies that are in use for this are companies like MongoDB with their document paradigm. A document is really the same as a key value access in that you have a user ID and then a rich set of information about a particular user. Cassandra is also often used in key value cases where you're trying to access a single user, but are able to do that with a larger cluster. Cassandra is also used in analytics cases for time series. Redis, I mentioned before, is one of the darlings of social networking due to its very high performance and RAM speeds. Compared to a MongoDB or Cassandra, Redis is really the speed winner on a single server basis, as well as having some really nice application-friendly programming paradigms. Aerospike, in contrast, has a lot of the speed capabilities of Redis, being also a C-based application with replication, and yet also has the kind of clustering capability that is available in Cassandra and MongoDB. So we find that Aerospike is really one of the best of both worlds in order to be able to provide both clustering and scale out, being able to add a few servers here and there as you're seeing load increase, as well as providing simple high levels of performance in the tens of thousands, hundreds of thousands, and even in some of our new benchmarks, the ability to run 1 million transactions per second on an Amazon instance. So another important factor and best practice now is to start using Flash as part of these in-memory designs. When we say in-memory, the first thing we think of is RAM. RAM is fast, RAM is flexible, RAM has a lot of random access capabilities, but as soon as you start saying RAM, you start thinking about systems that are bounded in the range of, say, hundreds of gigabytes or terabytes. And that is absolutely a fine design center for many, many applications. One of the developers and companies relying on Aerospike today, a company in India called Snapdeal, uses their core transaction system with all of their inventory, what the shipping levels of all of their products, and they use Aerospike in order to do that, and their data set size is only, I believe, 20 to 30 gigabytes. That's a great RAM data set size. However, some companies, and the advertising companies in specific, have started innovating around tracking a lot more users and a lot more user information. Once you start talking about tens of terabytes, once you start talking about tracking every cookie into your website or loading information from a DMP like BlueKai into your application's website, suddenly a 10 terabyte or 20 terabyte system seems like a good idea. Now that we have laptops capable of running with SSD and flash in the 1 terabyte range, it starts to seem possible to run a data center grade system that is also in the 10 to 20 terabyte range. Aerospike's capabilities but also experience with flash has been very positive. So we've found that folks within data centers are using data center grade flash more and more. And most importantly, a lot of the public cloud vendors, really all of them, have now adopted and embraced SSDs. We find that Amazon has released a whole new tier of SSD-based systems. They're now on their 2nd generation. Google Compute Cloud has recently announced, but not made fully public, their entirely new SSD-based tiering system. Rackspace and SoftLayer innovated in this area a long time ago and have gone through several generations. So that has driven a lot of the use of solid-state flash, the fact that we see a lot of these cloud providers already betting on it. So what are some of the best practices within flash? First is that flash does vary a lot by manufacturer, and enterprise-grade flash matters. I've had some customers of mine using consumer-grade flash that we did not recommend and not put through our benchmarking system and have some pretty poor experiences. So even though Aerospike is a clustered database and they were able to survive some serious hardware failures with consumer-grade devices, what we found is the major manufacturers, ones that are integrated manufacturers like Samsung, Micron, and Intel, companies that have their own fabrication lines, have their own controllers, are some of the best bets in terms of supply. Prices right now are running in the range for enterprise devices of $2,000 to $3,000 per gigabyte or $2,000 to $3,000 per terabyte. This is a very reasonable amount of money for the kind of million transaction per second systems that you can achieve using a database like Aerospike. We specifically recommend that people do not use RAID, but it is possible to use SATA or use some of the new PCIe-based systems. We have some interesting results and blog posts and case studies using what I call a wide SATA distribution. In a wide SATA system, you use a lot of SATA devices and in a standard JBAUD array, or use PCIe-based systems. I get a lot of questions about write durability of flash. It turns out that, first of all, modern enterprise flash systems are capable of quite a lot of writes before failure. The spec is often created in terms of drive writes per day, the ability to rewrite every single byte on an individual drive how many times per day before you start having write durability problems. Many of the companies in their enterprise lines are listing times of, say, 5 drive writes a day for 5 years. So you can rewrite every byte in a 1 terabyte system 5 times every single day for 5 years. What I find when we spec out these systems for potential customers is that if you're going to be reading from the database at the same time, you're not going to be writing from it at an extraordinary rate. These kinds of rates, like 5 drive writes per day, also allow the kind of read access that you're going to need. And rarely have we needed to require a customer even to step up to a system like some of the older SLC systems that had higher write durability. So having an in-memory database that gives you both MLC type price per byte at one speed level, SLC at another higher level of price, or even the ability to run RAM-based systems for even hotter data is really an important part of being a great in-memory databases. And our experience with Flash over the last 5 years has been extraordinary. We've had thousands of devices in the field with many customers running 100 terabyte systems, and the drive wear and drive failure levels are very manageable, easily lower than you would typically have in a rotational-based system. So we find Flash, if you are buying from the major providers of their enterprise-grade systems, to be absolutely worth it. The next recommendation is to use open source. Now, the adoption among enterprises of open source has radically changed just in the last few years. I think that many of the CIOs and CTOs are now creating even a requirement that databases and new data layer systems be open source. The benefits of open source go beyond price. I find that people who care about reliability and uptime are willing to pay for professional software created by industry insiders. Price is not the primary issue. The issue is trust, debugging, and technical capability. And in order to underscore this, let me tell a little story from my days at Netware. Netware was, in the style of the times, of course, a closed operating system, but it was one that was very peculiar. It was a very, very fast operating system, but very hard to program in. If you remember at that time, Netware was overtaken by Windows NT as a server environment, primarily because Windows was easier to program in. Even though it was slower, it had a lot more capabilities and was a friendlier environment. As an insider working for Novell, I could actually go read the kernel source code, and I did that time and time again in order to create the video serving and file serving applications that I wrote. There was no way I would be able to achieve my goals technically without being able to simply read some of that source code. And that is one of the great benefits of open source. So even in a model where the community is contributing just the occasional patch, simply having your ability for your technologists to go and read and understand that source code is absolutely invaluable. And I recommend that now to anyone working in this space. You have to be able to use open source simply for the technical capabilities. Second of all, the issue is trust. You don't want to depend on a data layer only to find out later that that innovative company has been bought by a large provider, and they're going to jack up the price or create other problems or close out the source. We've seen that time and time again. And within databases, of course, what has happened with NoSQL and Oracle, and now the alternate providers like MariaDB coming in and continuing innovation within that space is a great example of why you want open source, simply to provide longevity of these crucial application layers. So to sum up, that's 5 specific recommendations. Build an application-specific data layer, focus on key-value interfaces, use in-memory NoSQL, use Flash, and use open source. Now, Aerospike's capabilities in this area are widespread within advertising, and as I've said, we've seen a lot of new enterprise use cases. The ability of Aerospike to provide a level of performance much above even the other in-memory NoSQL providers, the ability to scale out, the ability to provide open source access, and proven reliability over years and years of uptime within demanding Internet applications is why people are reaching to Aerospike now, just to start even smaller projects, because they know if they keep to key value and if they keep the Aerospike APIs in use, they will be able to scale those applications reliably and price effectively. Aerospike also provides the ability to switch and provide multi-cloud environments. We have a lot of customers and a lot of users who get started in Amazon or get started in Google Computer Rackspace and then might migrate as an application or use case takes off to an internal cloud where either hardware is cheaper or perhaps the rest of their data and application layer is. Those are some of the great reasons to choose an open source database like Aerospike. So to wrap up, Aerospike is a database that provides really all three: speed, scale, and reliability. The ability to have internet scale reliability. When has Google ever gone down, right? These things stay up, as well as being able to take internet type loads, peaks, and spikes, as well as to be able to create new innovative application frameworks, are really why you need a NoSQL in-memory database. And I strongly suggest you have your technologists or you yourself check out Aerospike's open source offerings in order to see what Aerospike can do and really what you can build that's new with Aerospike. So this wraps up our webinar, and I want to thank you all for sticking around during this period. Hopefully you've learned a few things and gotten a few new ideas. There's a few questions that have come in during the course of the talk, so let me get through to answering those, but this is the end of my prepared remarks. So one question came in from Gu Patel, who said, are there any driver-specific changes you need for SSDs and flash storage? If no drivers are required, then what are the flash-specific optimizations? Aerospike does not require specific flash and SSD storage drivers. We work with every flash device on the market. As part of the research and innovation that Aerospike did, we looked at controller technology and fundamental chip technology that is shared across flash. We found that using in-memory indexes, which is an old database technique, provides a level of parallelism and concurrency that flash requires. A lot of this is covered in the architecture section of Aerospike's website, but really a couple of those innovations of using multi-threaded programming, deep queues, which allow SSDs and flash to go out faster. We found that some of the next generation in-memory NoSQL databases are used what's called memory mapping to access flash, which doesn't allow the same depth of queues and the same amount of parallelism that Aerospike does. So there's a couple of key technical innovations that are generic to the driver level. Earl Mitchell has asked the question, what is the market share rankings for in-memory NoSQL players, i.e. who has the most deployments? This is a very hard question to answer because so many of the deployments are done without the knowledge of any vendor. Analysts like Gartner are out there trying to measure them, but honestly, internet companies just pick up databases and run with them. By far and away, the most popular in-memory NoSQL database is MongoDB. This is a technology that has excited developers and allows them to very quickly and easily get started with application layers like Node and build very interesting applications very, very quickly. We've also found a lot of use of Cassandra, especially in the retail space, because it does have the capability to scale. Some of the things I hear about Mongo really do focus around easy to get going, but once you actually get going, you're going to need a technology partner or a consulting house to really keep MongoDB running at higher and higher levels of scale. Cassandra, on the other hand, is a technology that is built from the ground up to scale to much higher levels, even though performance per server, as it is written in Java, and its flash capabilities aren't quite up to some of the other players. Redis, I had mentioned before, also has a huge amount of market share, but as a pure open source product, there's no company that supports Redis. There aren't that many tracking numbers about who is actually using Redis and how. And that's also true of some of the oldest NoSQL, such as Memcache. There are a lot of providers out there, and to try to run through the laundry list would be difficult at best. So Scott Kruger has asked the question about an agile application layer. You mentioned using a predicate-based query engine. Is this really just the ability to create a query language that applications can use and plug in and out different database techniques? Yes, it is similar to that, but let me suggest one twist on it. It's not just, it is a DSL query layer, and it's a data service layer query language. In older technology and older terminologies, it's meaning being very strict about your data layer design and creating a strong ORM layer that is actually enforcing different application policies. That's what I've seen succeed in these scale-out systems. If you create that language, create a way for application guys and scale guys to speak together that is domain-specific, DSL, it's not as much of a query language as it is an API-driven development. But yes, that is exactly what we're talking about here. Instead of simply letting your application developers execute any query in the world, give them a domain-specific query language, a domain-specific API that allows these two groups, different constituencies, a DevOps-style constituency, as well as a fast-moving app group, give them a way to talk together. That's what I've seen work. Ricardo España has asked the question, what should be the parameters to decide what data should go in the key value in-memory technique? Well, the answer is really to put as much as you can in the key value side. So if you think of that separation, if you think about the idea of having a data warehouse or cold storage layer, as well as having that operational tier, what are the components of an application that need to be on the operational side? Well, on a retail site, that might be for a given user that comes in what their list of deals are. Instead of having that as a separate table with an index, that a foreign key that has to be joined against, thinking of that as a key value access. Oh, there's a table with an ID. I'm going to use that as my key because I always access deals by looking at operationally for a given user. I get the user. I see if there's been an analytics job that's created a set of deals for them, or I see some parameters that I'm going to throw into a machine learning project in order to do that kind of recommendation in real time. That's the kind of application design that is going to take you very far in terms of scale. If you start using various query layers and think about larger tables with multiple indexes on it, that is where I have found projects get into trouble because those kinds of indexes simply are not well optimized for internet scale. I think you'll find when you start thinking through your application that key value is a much, much richer paradigm. Really, this is an old database technique. The idea of using primary keys and driving primary keys as hard as possible throughout your application has really been a key to scale. Gu Patel has asked, how is Aerospike different from Memcache? Memcache is a great technology that has been used in caching layers since certainly around the 2000 year to complement relational technologies. And Aerospike can also be used as a caching layer, but as a persistent caching layer. So similar to Redis, Aerospike has column values, typed fields, the ability to write user-defined functions, but even goes beyond some of those in order to provide some analytics capabilities on the frontier. So that kind of rich capability, as well as the ability to cluster out, which Memcache doesn't have internally, although there are layers that you can provide, sharding layers on top of Memcache, Aerospike's clustering technology really gives the ability to simply add clusters or add nodes to a cluster or respond to network events without any problems. Memcache is usually seen as a non-persistent layer as well. Aerospike, with its flash technology, is on a row-by-row basis ACID compliant. You can find some of the information about that on Aerospike's website. And Ricardo España has also asked the question, what should be the business patterns in an app to achieve maximum transactions per second? Well, the business patterns that you're going to look for are real-time applications. Those are the business ideas that are becoming innovative, like I was saying, in the areas of, say, telecom and networking to provide better and finer-grained quality of service. That's what it's going to drive, applications like that, drive the need for transactions per second. Once you find those cases, again, you'll find that they are primary key-based access patterns for the highest level of database speed. You'll start finding that there are business indicators that require vitality as well as a lot of data, often coming out of big data analytics, that will really drive your application to new cases. So that's the questions we've had today. I hope you've enjoyed the webinar and have some new ideas about how to bring NoSQL technology, in-memory technology, and really the capabilities that are now coming out of Internet companies and Internet suppliers, such as Aerospike and the other NoSQL providers, that can really provide your business with maybe some new, fresh ideas and ability to compete and succeed in the Internet world that we live in. A lot of mobile out there, a lot of interaction. We need some better use cases going beyond the static into real-time and very personalized applications. This technology is out there. It's been used in advertising companies on the cutting edge and is now driving into retailers. It's driving into telecom companies, into banks, etc., for companies that really need to compete with the innovative, disruptive Internet companies out there. So hopefully you've gotten some new ideas about technology and best practices you can bring into your organization. And thank you very much for joining this webinar.
Thank you so much, Brian, for being with us today and for presenting an outstanding webcast for our audience and for sharing all your knowledge and expertise.
You're welcome.
Folks that attended our webcast today, we thank you for attending and hope you've benefited from it. And as we close out today's program, we'd like to say a big thank you to Aerospike for sponsoring our webcast today and let you know Aerospike is the world's first in-memory flash-optimized database, an in-memory NoSQL database that does at least three things really well: speed, scale, and rock-solid reliability. Aerospike makes scaling easy. It powers 2 out of 3 of the biggest real-time bidding platforms that operate at or near Google scale. Platforms like AppNexus, BlueKai, Chenko, Exalate, and X+1. Some databases are fast, some databases scale, and traditional relational are reliable. But no database operates at extreme low latency, under 1 millisecond predictability 95% of the time, while also scaling to well over 100 terabytes of data and doing all this nonstop, around the clock, 24/7 with no service downtime and no data loss for almost 4 years now. Thank you again, Aerospike. Folks, this will conclude today's webcast. We hope you benefited from the program. Thank you very much for joining us today. Goodbye, everyone.